Welcome to Municon 2021. I am Laura Froelich with Snohomish County Surface Water Management, and I will be moderating the session, Drones as a Tool for Stormwater Projects. Today we have with us Kelsey Mach with Landau Incorporated and Matt Balder with Thurston County. Please type your questions into the Q&A box and we will be answering them following the presentation. All right, I'm going to hand it over to Kelsey.
Awesome. Thank you, Laura. So I'm excited to be here today. I'm going to kick things off for this presentation. So as the title implies, we are going to be talking about drones and how you can use them for your stormwater projects. And then specifically, Matt's going to go into some projects that he's worked on with drones and stormwater at Thurston County. You can go ahead and click next, Matt. Thanks. So this is just an outline of the presentation. So we're going to give a little overview of ourselves, talk about the advantages of drones and specific sensors and platforms that you can choose from, a brief overview of data collection and processing procedures, and then Matt's going to go into some stormwater specific applications. We'll talk about both applications we see for the future and specific applications that we've used drones for, or that Matt's used drones for. And then Matt will touch on establishing and maintaining a drone program specifically geared towards municipalities. And then we'll briefly touch on the challenges of drone use that we've encountered. So I'm Kelsey, and I'm with Landau Associates. I am a project geologist, but I've been using drones for the last 4 years through my master's degree. And also I did a brief contract at the USGS National Drone Office in Denver. So drones have kind of followed me throughout my career, and I've been trying to incorporate them in my work at Landau Associates.
My name's Matt Balder, and I work for Thurston County Public Works as a assistant design engineer. And I got my start in the drone space, using drones for things like mapping and kind of project-related documentation that really has helped me help my design process along. But it's also led to other things that I find drones useful for, and it's been a really interesting experience so far.
Awesome. So just to touch on the advantages of drones that we've experienced and we've seen kind of in the industry, it provides a high resolution of data. It's something that's easily repeatable. If you have a site where you're monitoring it over time, it's really easy to repeat a drone flight over and over to monitor change. It's relatively inexpensive, especially when compared to airplane-based imagery and even traditional land surveying, depending on your application. It's time efficient. It doesn't take very long to collect this data. And it's an innovative tool that kind of brings a little bit of excitement to the project because it's something new and interesting. And also it helps increase transparency in projects. If you have a lot of stakeholders and that are interested in your site, it's something that can really help create transparency for everyone involved, see what's going on at the site, and it's a very easy data to share with everyone. So I'm not going to go into this into too much detail, but I wanted to give just a quick idea of what a drone sensor and platform consists of. So platform is typically what you call the drone itself, and then drones either have their own cameras or sensors, or you can buy separate cameras and sensors and hook them on to a drone. The basic setup that most people start with is the quadcopter drone, which is to the bottom left there. And usually with a high resolution camera, and that's going to be your cheapest and your most basic setup, and usually it's going to cover a lot of what you want to do. For a more advanced setup, you'll have a bigger drone that's also more expensive, but it can also carry a heavier payload. So these are the kind of standard sensors that I've worked with and that I've kind of heard about. There are so many drone sensors that are coming out and continue to come out. This is a very widely expanding field, but this is just to kind of give you an idea of what the type of sensors there are available: multispectral for vegetation health, hyperspectral for more research-based projects, thermal, LiDAR, and then your standard kind of high-resolution camera. So then what do you do with the drone imagery? So this is just kind of typical processing for drone imagery. It's not going to be for every type of drone data, but this is kind of typical, which is using the drone imagery to create what's called a digital elevation model, which is essentially a grid image that represents, that creates an image that represents the elevations of a surface. And you get that by making what's called a point cloud, which those familiar with LiDAR know what a point cloud is. It's essentially a set of points that each have an XYZ coordinate. And what's cool about making it from the drone imagery is that you can colorize the point cloud. And then from the point cloud, you can also make a 3D model, which is just a continuous surface made from the point cloud. And then also an orthomosaic, which is essentially just like a base map that you can use. And to give you an idea of resolution, your digital elevation models and orthomosaics can be down to the 2 centimeter resolution, depending on how low you fly and how much area you need to cover. And to the left, you can see some images from projects that Matt's going to talk about in a bit, but just to give you an idea of what kind of data we're talking about. Okay, you can hit next. Yeah, so, and I'm not going to go into this too much either, but structure from motion photogrammetry is what is a type of processing algorithm that you use to process drone imagery. And it essentially, the basics of it is that it takes your drone images, a series of overlapping drone images, and you're able to take those images and calculate the elevations and make your point cloud with those images. And so there are lots of different software out there that are available and super user-friendly, have really good user manuals. And so I've just listed a few of them here. There's some that are computer-based that require kind of a higher processing gaming type computer. And then there are some that are online-based, and all you have to do is upload your photos, and then it processes it for you on the cloud and spits out your products for you. It just kind of depends on how into the details you want to be. I tend to like to be more into the details, but if you're just doing it and you don't really need to write a research paper or anything to support your data, then doing those cloud-based processing can be really convenient. And I'm just going to touch briefly on some potential applications I've seen for drone uses in stormwater projects before Matt goes into specifics. So as I mentioned before, increasing transparency with stakeholders. It's really easy to post this data online so that multiple people can see it if you wish. Stormwater drainage mapping. This is a big application that I see. You can take the digital elevation model and run it through GIS and give yourself flow paths like are shown on the bottom image that essentially show you the likelihood of where water is going to go. Monitoring of BMPs it takes, 10 minutes to put a drone up in the air and image a site. And then you're able to look at the site and monitor if the best management practices are occurring. And then also mapping and quantifying areas of different surface types at like a smaller scale. So if you're concerned with what the impermeable area percentage is, that's something that this could be really valuable for. And now I'll pass it on to Matt.
Thanks, Kelsey. So I'll talk a little bit about two of the projects that I've been involved with, stormwater related, using drones. The first one is this Rochester Stormwater Pond and Conveyance project. It was installed in Rochester, Washington, completed in winter 2020. During the project, we did a lot of mapping missions using the Pix4D software in the cloud. And we started before construction began and continued throughout the construction in order to capture a good record of the progress. And the image on the right here is kind of the interface of that Pix4D cloud. And you'll see at the top, there's a timeline, and each one of those dates represents a flight where we went out to the site and mapped it. And this was really useful for sharing project data. This image here shows the 3D model of the conveyance system and the pond. And it was really a great tool for communicating all sorts of things, including material quantities. That's what's shown here. You can get a cut fill quantity on a pile or anything else from the model that's fairly accurate, and it's just good verification for what's being done in the field. Another really useful thing is you can overlay into the Pix4D cloud a PDF of the plans for the project, and you can see how things are being built and if they line up with the plans as you're expecting. And you can take measurements, and then you can share all these annotations through the cloud to anybody interested or involved with the project. So the next project I'll talk about was a fish passage project, but it was before the project started. We needed to figure out the hydrology of the area. So we used the drone as a tool for scouting out the hydrology of a kind of a really complex area. And it did answer a lot of questions about the hydrology because it was a very braided system and hard to impossible to traverse by foot. So the imagery provided a lot of insight and justification to actually do the project, which would be replacing the culvert shown in the image here with a bridge. So here's kind of an example of some of the area that we're trying to figure out where everything's draining to. And another thing that we did is we used another piece of software based in the cloud. It's called Survey, and it's an interface where you can upload your drone imagery and also flight data that shows the path and the coordinates of the drone as it flew through the project area. So I'll play a short video here. This is the project area that we were working in, and all of the pink lines here represent the flight paths taken by the drone. And if you click on any of these paths, then you can go to that specific spot in the video. And it's just a really great way to jump to the spot you want to see and have it kind of coordinated with a map view and then the video play at the same time. So that was a useful tool, and also for sharing with people that were interested, and they don't have to try to figure out where this video is in space. So that was great. And so those are the projects. I'll talk a little bit about establishing and maintaining a drone program now. In order to get a drone program going, you really need someone who's a champion to get the ball rolling. And they have to have a vision for the program and be able to kind of generate momentum from their management. At least that's in my experience, kind of willing to propel it along. And then thinking about what group a drone program belongs in my experience, we had multiple groups that wanted to be involved in the program. They were Public Works, the Sheriff's Office, and Thurston County Emergency Management. So having the three of us together, it really provided a solid footing for the need to start a program. And so that was really good. And that really kind of got rid of a lot of the bureaucracy that's involved with making some of these decisions harder for other groups that I've heard of. Communication with other staff and both inside and outside the drone program is really crucial to making it successful. Staff on the inside need to be kept up to date with rapidly changing technology, and then staff on the outside need to be made aware of what the drone program can actually accomplish for them and how it can fit into their day-to-day needs. Regulations are definitely a big piece of this. There's FAA regulations surrounding drone use that need to be followed. And that hasn't been a major hurdle at all in my experience. Basically boils down to keeping up to date with, it's called a Part 107 certification to be a remote pilot, and then equipment registration with the FAA as well. So that part's been fairly straightforward in my experience. UAS policy and operations. This is a really something we spent a lot of time crafting, and it was for the policy, we chose for Thurston County to develop an umbrella policy for the Sheriff's Office, Public Works, and Emergency Management in order to kind of make everything transparent to the public. It was a really useful tool. For the operations and procedures part of it, we developed our own for Public Works because we have our own missions compared to the Sheriff's Office and Emergency Management. And those documents I'm willing to share with anyone if anyone is interested in seeing those. Equipment management. From my experience, the equipment is very easy to manage. There's not a lot in the way of maintenance. We use DJI products, and I think we will continue in the future. They've been really great. We use the Phantoms and the Mavics. And my experience with drones in general, the biggest maintenance aspect is keeping track of the batteries and their health and how many cycles they have on them. So I'll talk a little bit about challenges of drone use now. We have the cost. So there's the cost of the equipment itself, which is not a whole lot compared with the upfront cost of training of people to use the program and ongoing costs to keep the staff up to speed. So that's a big one to consider. Acceptance of the technology. I feel that the general public is being more acceptant of the technology as they understand what we're using it for, and also internally acceptance. Sometimes I've heard of different agencies having people say that the use of drones will take away from their current job duties, but in my experience, it's only aided or made things easier for them. Communicating the capabilities of this new technology internally in my agency is very important. If nobody knows what they can do, then they won't ask for those services. And so, and it also if people realize what it can do, makes a stronger case for keeping the program. For learning curves, the big ones were regulatory with the FAA and figuring that all out. Technological, just figuring out what the drone can actually do for you and how to use it. And then finding a good fit for this technology within your specific group is another big learning curve. It is a rapidly advancing technology. It moves really fast. So keeping up to date on what's capable and what's new, it really is important, especially here, because things change all the time, and it might be worth upgrading your equipment even when you think that what you have is just fine. And privacy concerns are definitely there. The way that Thurston County has been addressing those privacy concerns is in our policy. We state that we will do things like do our best to not take imagery of people's homes, and we have a records retention schedule that we follow to kind of address those concerns. And so far, and we also have that policy up for review every year. So that's been good. And we haven't had any issues with the public saying anything about privacy so far. So that's been really great. So yeah, I think that's about all I have to say on this slide. And that pretty much wraps up our presentation. So I think that we're open for questions now.
Yeah, definitely. And I'm seeing one in the chat. I see several, so I'll just start with the first one. Have you found the measurements to be as accurate or more accurate than typical field measurements?
I would say that they're more accurate. Field measurements are things just like using tape measures and that stuff. I would say that it's the same level of accuracy that you could get with a handheld GPS data collector.
Great. So the next one, you mentioned gaming computers to help process the data from the drone. What rig do you personally use for this? And is there any minimum specs for the processor, graphics card, or as a whole that you would recommend for the job?
I feel like I have that written down somewhere, but I don't have it on the top of my head. But yeah, I usually just tell people like good graphics card is the most important thing, because otherwise it's just going to be, it turns like a week of processing into maybe like a day of processing. So we have at Landau, we have a modeling computer that we use, and that we designate that for our primary computer.
Thank you. I see one that I know the answer to. Yes, this presentation will be available up to 90 days, I believe, so we can get you more information on how to access these presentations. And then the next question is, have you ever used your drones to transport anything to or from your project site?
I haven't personally done that on a project. I've experimented with that on my own. I've got a drone with like a payload mechanism on it. Yeah.
Great.
Yeah, I feel like the biggest thing would be just making sure that whatever weight that you're trying to carry, I've seen people do it. I think the biggest thing is just making sure your drone can carry that amount of weight and that it still flies well. So definitely doing lots of test flights, because you don't want your drone to like flip over or something. But I think it's doable, but not personally done it.
Okay. Thank you. Have you observed any negative effects on wildlife from the presence of the drones?
I haven't. I've only observed curiosity, usually from hawks, and even the drones are getting quieter too. They have low noise props. Sometimes when they're over 100 feet up, you can barely even hear them.
Okay,
Yeah, I would agree. And at USGS, we did have a hawk who was very interested in one of the drones we were flying, and he actually knocked the drone out of the sky. But I would say that's a very rare occurrence. And the hawk was fine. We just yeah, the drone was not, but the hawk was fine.
So are there any issues with getting waivers to fly in more restricted airspace?
From my experience, trying to get a waiver to fly in a restricted airspace that you can't easily get through other avenues, it has been almost nearly impossible.
But there's that website that the FAA has now where some, depending on the airport, because the restricted airspace is mostly airports, depending on the airport, you can get automatic waivers, but like Matt's saying, if they're not a part of that program, it can be you have to go through the FAA, and it's a little more time intensive. And also with I've flown in restricted airspace and I got an FAA approval, but my drone wouldn't let me fly because of the app, and I had to do some fancy thing to get the drone to unlock. So that's something to consider to prepare for if you are going to have to fly in restricted airspace.
Definitely, yeah. I've been through that same thing as well. And one thing that we were able to do for our drones is, since we could be called for an emergency response or something, we were able to get DJI to give us it's kind of like a nationwide airspace unlock. So you still have to follow the regulations, but you don't have that extra hoop to jump through with your equipment to get it to fly.
Thank you. So in your guys' opinion, can the drone gathered information completely replace surveyors on the ground? Will that be the future?
Well, so sorry, Matt, go ahead.
Okay. I'd say it wouldn't replace the surveyors on the ground anytime in the near future. But it definitely helps their job. So.
Yeah, and I'll just add that I'm back on the accuracy question. If you want to get super accurate drone survey data, you need what are called ground control points, and those are multiple surveyed locations that you kind of reference your drone data to. And so they kind of work in tandem in that way, but the drone data is able to give you a more complete data set. Because you're getting points every centimeter. And so I think they kind of complement each other. And I'll also add that if you're just doing the photogrammetry with the drone imagery, you can't see through trees. And so if you're trying to get the elevation of a surface that's below vegetation, surveying or using LiDAR would be better than using the drone imagery.
Yeah, I might add that as we move forward and we're starting to fly LiDAR sensors, there is the real potential that could take a lot off of a surveyor's plate. But we're still going to need people on the ground to say, this spot is this exactly. They might be defining something like the edge of a curb or something, but then combining that with what we get from a really robust LiDAR flight, we could be seeing data sets that are much better than what we get now.
Thank you. So it looks like we're almost out of time. So I just, for any of the remaining questions, please email those or contact Matt or Kelsey directly. And thank you guys very much for presenting on this interesting technology. And thank you all for attending today.
Thank you.
Yeah, thank you.